Conference 2020, Breaking the Norm, Bridging the Gap. My name is Stephanie and I'll be emceeing today's event. Before we begin, I would like to introduce a few house rules for this event. Throughout the conference, please mute yourself. Please feel free to turn on your cameras if you'd like. Today's session will be fully recorded. If you have any questions, please leave them in the chat box and they will be addressed during the Q&A session. You can also contact the LSESU Actuarial Society email at lsesuact@gmail.com for assistance if you have any accessibility needs. As this session is 2 hours long, feel free to grab a drink and a snack to keep hydrated throughout the event. Be sure to stay until the end of the event for a chance to win a £10 Amazon e-voucher. We now start our panel discussion session. Before that, I would like to recommend the settings for your Zoom to maximize your experience during this conference. We recommend the side-by-side speaker view. To change your display to the setting, click the top right corner on your screen and select the speaker side-by-side view, which is the second option from the top. We will now start our panel discussion session. Artificial intelligence is set to disrupt almost every industry in the economy. No doubts, many of the traditional skills of actuaries will be threatened by emerging technologies. Today, we welcome our distinguished panelists to discuss this threat and how actuarial science and the profession in general plans on adapting data science techniques, technology, and artificially intelligent products. Joining us in today's panel discussion are Dr. Louis Pryor, President-elect of the IFOA, Lauren Sabati, co-founder of Skyline Partners, Dimitrios Velmahos, an actuary of 20 years international experience, and Mohammed Reza, actuarial associate at Genvi. Today's panel discussion will be moderated by Dr. Yining Chen. Completing his PhD in statistics at the University of Cambridge, Dr. Chen is now an assistant professor at LSE Department of Statistics and is currently doing his research which focuses on developing new methods for statistical problems, such as change point detection and non-parametric estimation. Dr. Chen, the floor is yours.
Thank you. On behalf of the Department of Statistics at the London School of Economics and Political Science, a very welcome to everyone joining this event on a rainy Saturday afternoon in London. In this session, we have 4 excellent panel discussions. In the following, I shall introduce them to you one by one and ask each of them to speak for 10 minutes before moving on to our panel discussion. If you have any questions, please do save them, and you will be given a chance to ask them in the Q&A session later. Our first speaker is Louis Pryor. Louis has had a varied career as an actuarial consultant, academic computer scientist, software risk consultant, and climate risk specialist. Along the way, she led the development of the technical actuarial standards at the Financial Reporting Council. She is the president-elect of the Institute and Faculty of Actuarials, chair of the London Climate Change Partnership, and non-executive director of the Ecology Building Society. To you, Louis.
Thank you, and welcome to everybody. And I'm sorry that some of you are getting me twice today. As I mentioned this morning, I did a PhD in artificial intelligence, which I gained in the early 90s, so about 25 years ago now. Things have changed a lot since then. In those days, artificial intelligence programs were mainly, but not entirely, qualitative rather than quantitative. We weren't making the big use of statistics that we can do nowadays. And that was because we simply didn't have access to the computing power that we do have now. In those days, AI had been through a big boom. earlier in the 80s or so, and we were in what was then called an AI winter, because people said, well, AI will never come to anything. In fact, of course, that wasn't true. What had happened was that a number of useful techniques had been developed by AI researchers and were actually being used by real people in the real world. But of course, if it was easy enough to build something that actually worked, then it didn't count as AI. And I think that's an example of what we see over the years, is that AI changes its definition. As we get better and better at making smart, helpful, useful computer programs, they sort of slip out of what's called AI. Take Siri and Cortana, for example. 10, 20 years ago, we could never have dreamt that anything could have been like this. So what we have today is an AI that's primarily based on statistical techniques and large amounts of data, which is fantastic, and it's doing some really useful stuff. And one of the questions we've been asked to think about is, will AI bring disruption or assistance to the actuarial industry? So my answer to that is yes, it will. Yes, it will bring disruption, and yes, it will bring assistance. When I started out as an actuary back in the early 80s, and I hope you're all sitting down, we did not have spreadsheets. There was no such thing as a spreadsheet. The way we performed calculations was either using pencil and paper with the aid of a calculator, or we wrote computer programs to do the calculations, usually in Fortran in those days. We didn't type, we were just starting in those days to type things directly in on keyboards and so on, but we tended to store our computer programs either on cards or on paper tape. This was a long time ago in computer history. Back in those days, in the early 80s, people were saying, well, of course, we're not going to need actuaries, and accountants come to that. We're not going to need actuaries or accountants in 10, 20 years' time, because spreadsheets, this new wonderful technology that's coming in, is going to replace them. All actuaries and indeed accountants do is they sit there and they add up numbers, and spreadsheets can do that just as easily. Well, as you may have noticed, that simply didn't happen. Instead, what happened was actuaries took to the new tools, spreadsheets, like a duck to water. Spreadsheets very soon, very quickly, I would say within, certainly by the time, within about 6 or 7 years of my starting work, actuaries were absolutely indispensable. Spreadsheets were absolutely indispensable to actuaries. But they changed the way we work. We didn't spend our time, or the actuarial students had, in those days, had been spending their time adding up numbers. Instead, actuarial students spend their time building spreadsheets to do the calculations. And eventually what that meant was that actuaries could do much more interesting calculations, much more detailed calculations, and we could develop whole types of models that we hadn't been able to develop before. We were able to do whole types of analyses that we weren't able to do before. And I see the same happening with the data analytics techniques and the AI techniques that are coming in now. A lot of the data analytics techniques that people do, people don't sort of necessarily think of them as AI, but 10, 20, 30 years ago, they would have been considered as AI. So basically, as AI advances, bits of it sort of drop off, cease to be thought of as AI, enter the mainstream, and become widely used. And I think that's what's going to happen. AI will allow us as actuaries to do all sorts of interesting analyses and make much better models than we've been able to in the past. It'll enable us to think of our problems in different ways. And it'll mean that we as actuaries can bring better tools to bear on our problems. What technical skills will an actuary need? Well, some actuaries will actually be working in the heart of it, as it were, developing the statistical techniques that allow us to do better things. But a lot of actuaries will be working with those more core technical specialists, and they'll be thinking about what sort of questions do we want to answer? What's relevant information? There's so much data out there now that one of the problems with these techniques is deciding what data to use. What's relevant? All sorts of interesting problems there. Some problems it's very clear. So a lot of image recognition work, for example, you don't need much information that's not in the image, because we can recognize images that we can recognize images just by looking at the picture. You don't have to, in many cases, you don't have to know much about it. But say you're trying to make inferences about people's behavior, about whether they're going to be interested in certain insurance products and things, you may need an awful lot of different information, not only where they live, how old they are, what other family members they have, all sorts of things that might potentially be relevant. And one of the things that actuaries will do, I think, in all sorts of ways, is to think about what information might be relevant. They will also think about the implications. You can throw data at an algorithm as much as you like, but what does it actually mean when it comes out? You have to think about what the limitations of the algorithm are and so on. There's a very, you may have heard the common expression, garbage in, garbage out, which means if you put rubbish data in, you get rubbish results out. But something we're increasingly hearing in the context of AI is bias in, bias out. And we have to think very, very carefully about whether algorithms that are being used are reinforcing existing biases. And that's one reason that the IFOA, together with the Royal Statistical Society, has developed a code of ethics for data science. So I think actuaries are going to be able to do much, much more interesting things with the development of these techniques. It will change what we do, it will change how we work, but it will make some of our basic actuarial skills about being able to look at the big picture, set problems in the context of the business as a whole. It will make those skills much, much more important. And that's all I've got to say as an introduction.
Thank you, Louise. Our second speaker is Laurent Sabatier, who is the co-founder of Skyline Partners, a parametric insurance company focusing on agriculture, renewable energy, and climate risks. Before Skyline, Laurent was chief actuary of ProSlide, a managing agency. Prior to that, he worked at AIG and AXA as a senior general insurance actuary in London and Paris over pricing, reserving, and capital. Over to you, Laurent.
Hello, everyone. Excellent. You prepared my presentation. Thank you very much. Yeah, so risk keeps evolving, and like all protections are also changing. And AI is actually a key part in this. And I will actually describe how a new type of insurance, called index insurance, is also making use of this new technique, all driven by data and technology. So in the current context, when you change and pandemics and the impacts that it has on the current business aspect and potentially on the future of our economy, new protections are required. So we need new solutions, and parametric one new type of insurance that will be very, very, very used, like in the current context when risks and the limit of uninsurability are potentially reached. So thanks to the combination of new data sources, so historical data, new satellites, but also technology, insurers can now offer very innovative solutions, which are all driven by data, where everything is automated and where the risk is measured, observed via this data, and index is triggering claim payments. So indexes are actually using, like technologies, but also like models, and AI is a key part in this. So I don't know if I can move the slide. Yes, I can move the slide. Excellent. So how index insurance works, like you would be selecting protections, that you want. We would be selecting, like the data to measure the risk, and the data will drive everything. And everything will be automated using that data. So I'm going to show some examples actually. So if you can pass the next slide. Yeah, excellent. So traditional insurance is, like in general, quite long, relatively cumbersome, quite administrative. It can take months to be paid. And it's mainly relying on the goodwill of the insurer to pay. And it's heavily manual to generate the payout. Index insurance, as a position, is entirely automated and uses data to measure the risk, and everything else is automated. So actually all the work is done upfront, pre-underwriting, and then everything is automated. So AI models and advanced data techniques are used to identify patterns in data and extract the risk information to structure triggers for the claim payouts to align exactly with the losses experienced by the clients. And we structure products using these techniques. Excellent. So it's actually a very, very good complement to traditional insurance. So it's not aimed at replacing traditional insurance. It's aimed at completing, like this type of protections where it's failing. So where you've got gaps in covers for hurricane covers, for instance, or earthquake in in regions of the world where actually these risks are so frequent that it becomes very, very complicated to insure them. The cost of insurance is too high, and insurers are maybe like also moving away from it because the risk is too large. So parametric insurance helps to solve this issue. It also helps to cover additional losses which are actually not seen, where the consequences are indirect, are not even perceived, or are perceived much later. So by using data techniques, you can analyze these impacts and structure indexes which will be covering these contingent losses. And you can also, like create very, very complex indexes, covering large portfolios and large risks which are emerging that are not covered by existing insurance policies. I don't know if you don't mind moving. So excellent. So it's fully transparent. It's very fast to pay out, guaranteed payout, because instead of having 100 pages of policy documents, you just have a formula, and the formula describes the index and how it works. And it's very flexible. Excellent. So I'm going to show some examples. So it's also adding, like to a risk protection, an information about the risk itself, which can be very useful for for companies or businesses where these risks are perceived but are not well understood. By getting access to that index, they can also understand better the risk and maybe make decisions, like as well as protecting themselves using that index. So, like in terms of perils, like that really, like are of interest for us. So I've talked about agriculture, renewable energy, construction, supply chain. The key perils, that we are looking at the moment are climatic risks, natural catastrophic risks, but other measurable risks where data can be used to observe and trigger these indexes. Excellent. So I've got some examples, like a little bit further down the line. But here, what is very interesting is that everything is driven by models and by data techniques. So from the risk assessment to the tailoring of the instrument, big data techniques, AI models are used, real world physical simulations are also implemented. To simulate, for instance, some hurricanes, the trajectory of the hurricane, how it's moving, like one by one, and how you can estimate the impacts of a hurricane, like on economic losses of the region, and therefore select an index that would be appropriate to protect agriculture businesses, for instance, in Caribbean. But we can also take the example of a renewable energy farm, so wind farm, how we could use wind speed to estimate the energy produced by the wind farm, and therefore the revenue projected, and protect the revenue of the wind farm based on a lack of wind input. Or we could also look at critical rainfall affecting the yield of large crop in I don't know, Brazil or India, and how like a rainfall, actually a week of rainfall at a specific growing stage of the crop will have a large impact on the final yield. And therefore, instead of waiting for the yield to be reported and assessed at the harvest and therefore pay the claim sometimes months after the harvest, you could therefore pay and reimburse, like a farmer when the rainfall is actually being measured, and therefore much ahead of when the losses are experienced. And this kind of protections can help, to sustain in very, very difficult situations like we are today. Excellent. So I mean, there are like other things I can talk about, but like it's all driven by technology and by data models. Thank you, and I will expand probably a little bit later on. Thank you.
Thank you. Our third speaker is Dimitris Mamachas, who is an actuary for over 20 years of international experience as an executive, consultant, and entrepreneur. His experience includes leadership roles in financial services and insurance and reinsurance industry, where among others, he held the positions of Chief Actuary, Director of Data Analytics, General Manager, Executive Director of Business Units, and Consulting Practices. Moreover, Dimitris has consulted independently and founded new ventures focusing on data, insure tech, and other optimization and strategic initiatives. Over to you, Dimitris.
Thank you very much, Yinin. Good afternoon, everyone. And what I will be doing in the next 10 minutes is basically trying to share with you my perspective about AI and actuarial and my experiences. So my presentation has basically 4 sections. The first section is around artificial intelligence, how I see artificial intelligence. There is a lot of hype around this new technology, and in a way, I will reinforce a lot of the things that Luis said before. The second part will be about the insurance industry and how I see the industry embracing this new techniques and technology. The third part will be related to how I see the actuarial profession in this period, and then I will conclude with some takeaways. So basically, let's start with artificial intelligence. So to a large extent, what we hear about AI is indeed a hype, and we need to be careful that I feel that we need to be careful that we still remain pragmatic, especially when it comes to applying this technology in industries that are not necessarily so straightforward or industries that have been quite traditional, like insurance. However, AI is indeed transformational. There is indeed an underlying asset that's very valuable, and we should be indeed embracing it. Now, we are at the moment in what we call the 4th industrial revolution. I remind, so we had the first industrial revolution, which was with the steam engine, which was responsible for the manufacturing processes. We had then 100 years later electricity and the combustion engines, which were responsible for mass production. And then we had the computer and internet, which were responsible for basically the digital revolution. Now we have the 4th revolution, as they say, which is related to artificial intelligence, IoT, connectivity, which is, you could say that it borrows some of the inventions from the 3rd industrial revolution, but you could say it's the 3rd industrial revolution on steroids. So it's much more enhanced. Now, what actually what has actually changed in the last years? So what has changed is that, first of all, we have much more computational power. We were, as Luis mentioned in her talk, we were using these techniques also in the past. And actually, one of the famous computer science problems, the 4-color problem, was solved not just with mathematics, but it was solved also with brute force computational power. They were using some machines that were running for 1,000 hours, but now we're in a total different game. So I don't know if you guys know, but recently we managed to solve the 42 to solve the problem of writing 42 as a sum of 3 cubes. Was unsolved problem for many years in mathematics, and it was solved because we have the computational power to achieve this. The second reason is that we do now have a total different data ecosystem. In the last years, in the last few years, we have gathered more than 95% of the total data that is out there. And also, we now have, because of technology, because of the connectivity, we have platforms that we can scale up these capabilities. We have cloud, we have open source, we can democratize, as we say, the knowledge. Last but not least, although the mathematics and the statistical principles remain the same, we do have developed some new techniques that fit quite well with the computational power, like deep learning. And this has resulted in some amazing achievements. And I'm sure you have been following what has been done with AlphaStar, with AlphaGo, with Image Challenge. Even AI now can beat the best poker players in the world. Maybe you have heard about the program Libratus. And actually, yesterday, when I was preparing for this talk, I saw that there is another application now that is even better than Libratus. Now, is AI able to solve, can AI solve, for example, the difficult problems like the Riemann hypothesis or the Goldbach conjecture? Theoretically, yes, if the solution is based on the acquired knowledge that we already have. Theoretically, yes. And is AI going to solve eventually everything? No, I would say. And that I have this opinion because basically the underlying mechanisms are mathematics, and it has been proven in mathematics for the mathematicians here in this forum that we have the Gödel's incompleteness theorem, which says that not everything has been proven. So this follows AI. What is the next thing in AI? The next thing is in AI is basically to move from what we have now as narrow artificial intelligence to general artificial intelligence, which basically means emulate the human capabilities, being able to solve things with less data, being able to explain, have explainability better, and being able also to transfer knowledge. Now, how is that connected with the insurance industry? Every line of business, so this is general insurance, life, retail, commercial lines, has been influenced by these new capabilities. Certain parts of the industry are ahead, like general insurance, which had a more data-driven culture than, for example, life insurance. Life insurance was more dependent on closed formulas. General insurance was more dependent on data. So general insurance, you will see they are more ahead of the curve when it comes to applying artificial intelligence. The other thing that you will see is that retail business maybe is a little bit more ahead than commercial business. Why? Because in retail business, we have probably better data quality than we have, for example, when we're trying to price a very niche risk, which is very low frequency, that we do not have the data that we will have, for example, for motor insurance, which is much more frequent and we have better data quality. What is at the moment the playing field for the insurance companies? Where are they trying to compete, and what will be the game changer for the future? Which is how are going to what is the competition at the moment? More or less, everyone is trying to do the same thing. They're trying to gather, capitalize as much as possible on new data. New data. They're trying to enhance their data ecosystem. They're trying to capitalize on external data. They're trying to find data that has predictive value. And by doing this and using these techniques, they're trying to create margins. And how are they going to basically scale those solutions? They're going to scale the solutions by deploying it to cloud. So you will see more and more the software as a platform. You will see more and more deploying this solution on top of operating systems. And this is actually how they're going to scale it faster and cheaper. And the end goal is basically to disrupt the whole value chain of the insurance company by being able to add prediction, insight, automate processes, and automate them, and also being able to interact dynamically in real time. Example use cases are endless. Here I'm putting some of the ones that I have been working with my teams in the last years. Lauren, just before, gave a brilliant use case in parametric insurance with his example. And his example was about underwriting. You will see disruption in underwriting, in claims handling, in reserving, in persistency, everywhere. So very dominant ones are in underwriting, are in claims fraud, where we're trying to use classification techniques, where we're trying to use data that are not necessarily obvious related to the problem that we're trying to solve. However, we see that they have predicted value. We have use cases around pricing in property. We have use cases in motor around pricing, where we use external and public databases that we have, for example, from police or elsewhere. And that's how we create better accuracies. First notice of loss, there is an accident with a car, someone takes a picture using deep learning, the machine decides automatically the severity of the accident. We have examples in insurance, where we're using natural language processing to go through treaties. The insurance industry have endless treaties, and that's how they are able basically to categorize and see their exposure. Now, there are challenges with this. And the challenges are not to be taken lightly. I can basically admit, having worked in transformation programs around AI, that it's not easy. And insurance industry is not particularly easy when it comes to adopting this technology. There are challenges around the organization, the leadership, the commitment. It requires good communication. It requires talent. And that's not easy to get. The infrastructure is not necessarily the most easy. Insurance companies are coming from many years before, when there is a lot of legacy when it comes to data. The solution architecture when it comes to deploying the solution, requires attention. Insurance companies are not academic environments. And then besides the algorithmic side around how we ensure bias, how we ensure that there is no bias, how we ensure interpretability, there is also a very important one, which is a vision. As you will see, the big techs are actually right now going to move to insurance more. You see Tesla has their own insurance vehicle, regardless who is the underwriter behind it. You see Tesla hiring now actuaries. You see Amazon that they're having actuaries. You see Uber that they're having actuaries. You see the big auto manufacturers that are actually trying to create their own vehicles. And you will see that motor, for example, insurance that I mentioned before is retail insurance. It's moving more. It's moving more to becoming a commercial insurance, where basically the manufacturer is going to be offering the insurance. So there is a very important question for the insurance industry to answer: how will they compete with these big tech companies when the big tech companies are better organized in terms of managing this data? They have talent, they have experience in this. Now, the next thing I want to talk is more specifically about the actuary. Everything. Yeah. Sorry?
One minute, please.
Very quickly, we're moving from traditional approaches to machine learning, and we have seen that the machine learning approaches like random forests, like gradient boost, like neural networks outperform approaches that were traditional, like GLMs or closed formulas. This is something that we see, so this is something real. And the actuary is very, very important in this because of not only he can understand the data science part, even if he's not a hardcore data scientist, but because of his domain expertise, because his business understanding, because of the understanding of how the industry works, and also very important because of the judgment. I can finish here. The last slide is just basically a summary. So that's all for me for now.
Thanks a lot. Our final speaker today is Mohammed Raza, who is actually an alumni from us, graduating in 2014 in BSc Actuarial Science. He joined January Life and Health pricing team in 2015 and has been working there ever since. He focuses on reinsurance pricing and data projects within the company, and he is the winner of the Actuarial Post Star of the Future Prize in 2019. So welcome back, and the floor is yours.
Hi, thanks for that. Hi, yeah, thanks for that introduction. I'm Mohammed, and I'm just going to talk to you just a little bit on a little bit of background on AI, just a bit of supplement information from what the previous speakers have said, and a bit of the role of the actuary and how that might change in the future, and what skills you may need to be able to develop your role as an actuary, and some current examples what's happening in the market currently with InsurTech, and seeing what's happening in that space. So I just wanted to give a quick background to what AI is. I mean, I think you probably all have a pretty good idea what it is. There are two different types. Well, you can categorize into strong AI, which is basically what you think AI is something that would replicate human intelligence, making machines think for themselves and applying the processes. And weak AI is something that we've pretty much been doing over the last 20-25 years, which is basically implementing rules-based task that focuses on particular narrow tasks that you want to achieve. So these are the two main types, and obviously strong AI is something that's been developing over the last few years with Siri and like Netflix recommendations, and everything that we see around is dominated by this AI. But at the moment, where we are particularly, I think, in the insurance industry is focusing more on the weak AI, and in particular machine learning techniques in how to, especially in different elements of the pricing process and reserving, and that's what we've been seeing in the industry over the last few years. A good GOFAI is a good old-fashioned AI, and that's just basically where you is basically weak AI and where you lay out the rules in advance. But machine learning techniques have really taken off over the last few years, especially within the insurance space. If you go to the next slide, please. So this is a quote from an article in the Actuary from Owen Lyons and Matt Oldham in I think this was an article last year in the Actuary, and it basically says actuaries will have to adapt to survive in the digital age. And I pretty much agree with this. And it just basically says, this article basically does say that a company, I think the company that they were mentioning in their article recently celebrated that a life insurance application took 20 minutes from beginning to end, and they were celebrating this fact. But however, given the trend of young people these days, in 20 minutes, you can do a whole lot of things. You could plan your night out, you can plan your outfit, you can watch a Netflix documentary, you can do lots of things in 20 minutes. And a life insurance company was celebrating that their application took 20 minutes. People don't have the time nowadays to spend 20 minutes on an application. So it's just basically highlighting that we'll need to be better at processing these applications, or processing generally how the insurance industry is kind of outdated in a way. So yeah, so people don't generally these days don't want to go through the hassle of calling someone, and yeah, and it's just basically highlighting we need to streamline this process, and we need to be careful of any disruptors in the market. For example, if Amazon were to launch life insurance, how that would disrupt the market, and people would just trust Amazon and buy their product, and we might cause other companies to fall behind. So yeah, this leads on to my next slide, which is basically the digital actuary. What can we do to keep up with this demand of this new world that we're living in? I mean, we've seen a lot of changes already. So for example, the IFOA have currently, I think some of you have, I don't know whether some of you have taken the IFOA exams, might be members, but once you start your actuarial career, the exams that you have to take are becoming more computer-based. So for 2019, the IFOA changed their exams to become more computer-based for the first time. The underwriter role is changing, in particular with machine learning techniques to try and streamline the underwriting process. There is the consumers are being taken care of more of their health digitally. What can we do to utilize that information in the life insurance space? And obviously there's been the ethics raised of handling this data with GDPR. So we need to be very careful of how we use that data, and how and whether the ethically using AI in the correct way, and not personally invading people's privacy. So as a result of all this, I think the actuarial skill set will change. It is currently changing. We have massive sets of data available. We have data currently being generated at an exponential rate at the moment. So I mean, there's a point where Microsoft Excel skills just don't cut it. So there's just lots of different data analytical programs out there like SQL, R, Python, which have been increase in demand over the last few years, and we as a company have been embracing these technologies, and there's a different skill set required to help deal with this change in the data that we receive. So it's important to be able to keep on top of this, so it's leaning more towards a data science skill set for an actuary, which there definitely is an overlap, which kind of leads to my next slide, which is just this is a slide from a presentation from two members of the IFOA, Mark Lee and Stelia Pasaris, in the role of the actuary in data science. I think the presentation of this was last year, and it just basically shows that the data scientist trend is mentions increasing upwards, but the actuary maybe is a bit flat and a bit declining. But there is so it just shows that data science at the moment is a hot topic that we need to consider, and that there's a definite overlap between the skill set of an actuary and the skill set of a data scientist, and how these how this will lead to a new way of working in the future. If you go to the next slide, I think last year the Institute of Actuaries released a data science webinar for actuaries to improve their skills, to make themselves more aware of what's going on in this field. As well as this, there's an IFOA data science certificate course that's currently happening to try and train actuaries into the newer way of thinking, which is what I'm actually currently studying for, and I think we finishing in the next couple of weeks or so. So I'm improving my skills in that aspect as well. So that's how perhaps the skill set is changing. And I just wanted to now move on into what key change and disruptors might see, what we've seen with AI recently. We've seen lots of people wear wearables, smartphone technology. What data can we extract from that? Are we able to extract data from that and perhaps use that in pricing life insurance? To what extent can we use that data? And also cloud computing is on the rise. Amazon Web Services, people are using that technology to help improve their computing processing power, which enables us to do all sorts of exciting things. There is now some blockchain technology, although it's very in the early stages of how to automatically pay claims within. So when like a claim event is triggered, it automatically assesses and pays that claim. That sort of technology that's in its early stages, but we could see how this could affect the industry, and obviously, as we all know, machine learning in all aspects of the business is what Dimitrios referred to in his previous presentation, and we've seen it in analytics, we've seen it in reserving, we've seen it in pricing, and how it will affect the industry. So I'll just quickly go over what January has done. We've just, as a company, we've just invested in some startups with some evidence and research. So our Asian team has developed a facial recognition app in Asia to try and streamline applying for a life insurance application. We've partnered with a few startup companies to try and see what's happening in that space, just to as we do believe that digital is the future. I mean, we can. So, for example, if you go to the next slide, we've got two next slides. Sorry, we've partnered with Pi, which helps track user data and helps potential policyholders to improve their life, their health, or their heart score. There's been other disruptors of insurtech like Torofogu Tech, which uses AI to help people with chronic conditions manage their life and potentially help manage to help keep their premiums low for life insurance. There's Dead Happy, who are trying to change the way life insurance works. With, for example, some of their benefits include Spotify accounts, etc., trying to appeal to the younger audience, and Shift Technology, who help try to identify fraud using AI. So I mean, there's lots of things happening in this space, and there's lots of investment that's happening. So we just so that's just a brief introduction to what's happening. If you go to the final slide, sorry. So yes, what's happening at the moment in the industry. We've got lots of different insurtech and startups that are making their way, and we need to be wary of what they're doing and perhaps embrace the technology that they're using. The life and health. So the life and health industry is changing in that way. We're changing the way we price and reserve using machine learning techniques and being more embracing of this change. But then we also need to consider the ethics of how much data can we use, how can we store that data, how to keep that data private. That's all a question that we need to be able to answer as well. But I think the general concern about all the people in this audience is whether, to link it to the main theme, which is whether AI will take over actuaries. I think I'll turn that question on you in that why don't you develop your skills? Why don't you use your skills or use your time that you have to develop your skills in AI and become the better actuary and use that in your skill set and improve your skills to become a better actuary and to help deliver better outcomes for businesses.
Thank you. In the following, we are going to have 20 to 30 minutes panel discussion. We've actually received a lot of questions from the conference participants and have summarized as the following. So let me go through some of them before opening the floor to the Q&A sessions. So the very first question is to ask about the change and transitions brought by AI that you've seen throughout your career. I think you probably have already mentioned some of them in your talks. And we are interested in knowing that how we can prepare for the disruption AI is going to bring to the actuarial industry. And more importantly, how should we polish ourselves to adapt to the evolution of AI? Any comments?
Okay, if I just start, I think it's just what I said previously. I think AI is something that obviously we need to be very aware of, and it's become a big, important part of our daily lives, and it potentially can disrupt the actuarial industry. But we just need to be able to adapt and utilize the skill sets of what AI needs. So being more aware of data science techniques that are being used to help price insurance products or reserve insurance products or whatever particular aspect of the business you're working in. So we just need to be aware and perhaps polish up your data science skills in this aspect, and just do some more research yourself. Really, I think it will just become an important part of an actuary's toolkit rather than AI replacing actuaries. But we just need to be more polished and evolve, basically.
Any other comments?
Yeah, so maybe a very brief comment. I liked actually the analogies that Louise mentioned at the beginning with the spreadsheets that were used as a key toolbox, to improve the way actuaries, like had an impact in the insurance industry. I think, AI is going to be the same. It's just offering us an opportunity to be seen even more across the insurance industry. And I would say that, like up until now, actuaries have been staying in quantitative position in actuarial, like teams mainly. In certain companies like reinsurers, in GI, maybe you can see them also as underwriters. But I would see actually the rise of AI techniques and like all these toolbox, help the actuary to get out of the silo of being an actuarial department only function, and actually go across all functions and have an impact across all operations in the insurance industry, and actually be even more core actually to the insurance industry. Because we would be the one who would have been able to harness this type of techniques.
So probably a more practical question to our student. So if they want to prepare to become an actuary in the future, what are the skills that they really need to polish or need to learn from their university studies? Do they want to spend more time learning how to code in Python or in Excel, or they also want to learn mathematical foundations of actuarial science very well as well?
If I can add here something again to your question, I think it is crucial for in this era for everyone to be a little bit of a software engineer. So I do not think that it's absolutely necessary for everyone to know every little secret of why an algorithm performs in this way or not. I mean, a good foundation is necessary. Anyway, actuaries are coming from generally good foundations, but in my opinion, it's not so critical to be a hardcore data scientist. There are also a lot of tools these days that are doing in an automatic way machine learning. And this will become more dominant as the time goes by. But what is important is to be able to connect the tools, to be able to use the tools. So being a very old school actuary that basically relies on an Excel spreadsheet and is not able to use Python, is not able to use the libraries that are out there, is going to be a little bit problematic, especially in certain lines of business.
Okay.
I can't agree more, Dimitrios. I really think that actually actuaries, like are becoming more, like software engineer, computing engineer, and statistician, than qualitative, like, I mean, giving a forecast, okay, what would be the trend for next year? I think we are definitely needing, like strong art skills, like in coding, and like, I mean, we can see it particularly in pricing and capital modeling in GI, for instance. Like the key skill sets for capital modeling are coding, building some complex statistical models, stochastic processes with a very, very high number of complexities in terms of unit of business, risks, and I've seen definitely the rise in this type of competencies over the years. I think Solvency II has created this need. It wasn't there before, really. I mean, capital modeling was quite simple, and even pricing was relatively simple and formulaic. Maybe GLM, like really showed the rise in this type of complex modeling. But I think that Solvency II and capital modeling has really brought, these needs of being able to code and build some complex analytical models who have actually like a big computing power. And actually now with the rise of cloud computing, parallel computing, I suspect that actually actuaries will have to know these kind of techniques as well, because the models will become more and more complex, will require more and more power, and we will need to know this type of technologies. And it's coming. I can see it already in my teams.
And one thing that remains the same, if I might add, is because we talked about evolution, one thing remains the same in the years, which is the data engineering part. So the data engineering part takes more than 80% in some cases of the work. So the actuary that is a technical actuary, if he cannot prepare the data, if he cannot do feature engineering, which in some cases is not necessarily just a technical thing, it's also a little bit of an art, he will not be able to create good outputs. This is remaining a challenge even now.
I see. Any further comments? The second question actually is quite relevant as well. A lot of students are wondering whether actuaries will be replaced by data scientists or statisticians or even AI with the changes in the job scope and development of the other careers. Especially with the success of experiments like AlphaGo, will it be possible for AI to reason like a pricing actuary or a life insurance underwriter in the near future? I think you probably have already addressed some aspects of this question in your talks before, but I think students probably just prefer to have more clarity over these issues.
Okay. Yeah, as I've alluded to before, I mean, we just need to embrace this technology, that it's coming and it may impact the way we work. It has impacted the way we work, but we just need to improve our skill sets, basically. I mean, I just wanted to turn, like I said before, I just want to turn it to yourself. If you're afraid of AI taking over your job, why don't you just learn the skill sets of potentially using AI to your advantage and helping you to become a better actuary. There's no reason why being an AI expert and being an actuary can't overlap. There's more than enough capability for everyone to be able to do that.
It is, and I still think that the like the two jobs and the two skill sets are still different. I completely agree with you. That like actuaries have to embrace like data science techniques and strengthen their skills like to improve their knowledge and their computing capabilities
Yeah.
over time. But I see an actuary as being a quantifier of risk. A data scientist is a predictor, and the two roles are very different. The quantification of risk, building some complex stochastic models, applying stats. Of course, it's linked, to prediction and potentially AI models. But like the skill sets, knowledge, the applications are still different. You see, extreme value theory. It's still very different to predicting how the weather will look like tomorrow. It's not the same to predict what will be the category 5 hurricane and what will be its impact with the probability of accidents, like I don't know, like a 250 return period, than it is to estimate what will be the temperature tomorrow. And I think that an actuary will still have, like a role to play, whatever, even if data scientists are rising. Actuaries have this role of quantifying risk, and I really think that it is a different job.
But what do you call a data scientist with domain knowledge in insurance and actuary or not?
So it's a good question, actually, because I really think that actually, like risk quantification is not only insurance related. So of course, the insurance industry has accumulated most of the requirement for actuaries because of the financial element and the fact that actually insurance companies have to put some money on their balance sheet and capitalize themselves based on an estimation of risk. They have to price, they have to reserve. So the actuary is in the core functions of an insurance industry. But an actuary is required in lots of other businesses. I think Dimitrios was talking, about other companies, bringing actuaries on board for insurance applications, but actuaries are working in other industries. The quantification of risk and putting a financial value on a risk is wider than the insurance industry.
If I can also add to this, to give my perspective very clear, it's impossible for the actuary, in my opinion, to be replaced. It's impossible. So if anything, his work or her work will become more exciting because there is an additional tool, which is a very powerful tool. It's impossible because the value of the actuary is not the computational accuracy or the computational power. The actuary is more of an engineer. The actuary understands the business, can understand the world of the data scientist, can understand the world of the insurance business, and is a bridge. But it is absolutely necessary for the actuary to be able to speak the new language. So an actuary who doesn't speak the new language cannot perform the role very well. But the future for this profession is the collaboration of the two elements.
It's a bit like, sorry, I was away there for a bit because my connection disappeared, but it's a bit like computer programming. I mean, actuaries in insurers rely on huge, elaborate computer programs. They understand quite a lot about those programs, what their limitations are, what their power is, but they are not necessarily the people who build those computer programs themselves. They use the programs as a tool. They work as in teams with the programmers to develop the systems. To use something, you don't have to be able to build it yourself. You have to understand what it does. You have to understand some of the concepts. But as actuaries, what we have to do is we have to put things in context. We have to see the bigger picture of, in insurance, what matters to the insurer as a whole, rather than just, is it producing the right price? Because there may be no such thing as a right price. You've got trade-offs, you've got judgments to make, and that's where the actuary comes in.
So the next question is also to do with big data. So considering the increased access to big data, how do you think the process of data sorting or data cleaning will get changed with the introduction of AI in the insurance industry?
So that's an excellent question. And I really believe that it will create jobs for actuaries. You see, like, for instance, I would not be surprised if there will be, like in a few years time, actuary functions called data actuary. Because, like, we've got data engineer, but I think the actuarial preparation of data is actually critical. The reliance on data is critical. Most of the underwriting is done, like using data now. Like everything is automated. Data is key in every part of like the actuarial processes. And the quality of the data is already, like a very, very big assessment, you see, for instance, in the regulatory requirements. But I really believe that actuaries will have a very big role to play in this, particularly if models are used. I think, data uncertainty and data quality will be creating more opportunities for actuaries.
Because we'll be using more data. This is the thing about the AI we're seeing, is it's mostly data based, and it uses huge quantities of data, and you need to understand what's in that data and what biases are in the data, say, in order to understand the results that come out of the AI systems. So that's, again, that's where the actuaries come in to it's the bigger picture thing again. I can see I'm going to be saying this all the time.
It is, but I mean, I can see the overlap between data scientists, data engineer, and actuaries here. You see, because actually techniques are very similar. When you look at data and extracting the information from the data, assessing the quality of the data, filling the gaps in the data, correcting the data, fitting data. I mean, all these terms are across all the board. You see data scientists, actuaries, and everything. I think what actuaries will be bringing is maybe the rigor, the norms. You see the fact that we've got code of conducts, that we are actually regulatory function. And I think it's very important to mention that an actuary is qualified, certified. He has to meet certain norms. And in an actual position in an insurance company, you have to make sure that actually the data that you use is appropriate. And that's part of your role. A data scientist is using data. Of course, he will do all of this, but technically, he will not be liable, for this. Actuary has also an element of liability in its core, and we are actually like, like almost the defend, like the ones, like who are defending these core concepts in an insurance company. And I think that will definitely be, like also strengthening the role of an actuary moving forward in all these positions.
So now that you mentioned liability, the next question is the following. With the uprising of AI and its widespread use in so many products these days, how should we allocate the liabilities in the case of accidents, in those like difficult cases, like you have an injury or death occurring in a self-driving car? Who and what should really be held accountable? And who get to define the value of human life, again, against what's that value being weighted?
If I can jump in, the legislation part might be different in every country, right? And the regulation might be different, but especially in your example that you mentioned for self-driving cars, although. And this also depends on the automation level. So different automation levels will have a different impact. But the general consensus is that the liability moves more to, as I said also in my presentation, to the manufacturer. That's the general consensus. However, the third-party liability, for example, is going to remain, and the actuarial challenge is going to remain. So the risks are going to be the same. What is different is basically where the responsibility goes. But there is a general consensus that we're moving, for example, from, especially in your example for motor, from retail insurance, where each individual needs to insure themselves, to fleet insurance, where the manufacturer takes care of the issue because it's his responsibility. If it is a full automated self-driving car, if there is a fault. But we are way to go to that, right? It's not something that it's going to happen tomorrow.
In the end, it's a question of the law. It's not the actuaries who decide who's responsible. It's society as a whole, typically through the government, through the judicial system or whatever. We can influence that because we are members of society. However, there's more to it than that. As actuaries, we're professionals. We sign up to a code of conduct. It's important that we think about our actions in the context of the bigger picture. And to my mind, our ethical code of conduct says that even if we are not legally liable for things, we do have to think about the impacts that we have. And to my mind, it would be unethical of us to, for example, develop an algorithm for a self-driving car and not do absolutely the best we could to make it safe, and to be very clear about the limitations of the algorithm, what might cause it to fail, and to warn people for whom we were developing it. That, I mean, we can't just develop, I mean, this is unlikely that actuaries would actually develop algorithms for self-driving cars, but I'm just taking the example. And
yes.
and the same is true for machine learning we use actually in insurance, for example, for pricing and that sort of thing. If we're developing algorithms that exclude a segment of society for no good reason, that are biased, we should be very aware that that's what's happening, and we should warn everybody that that's what's happening, and we should do our best actually to avoid that.
Completely agree, Luis. I was actually just going to comment on this. So I think it's absolutely right. I mean, on the self-driving car, I think it's very unlikely that actuaries are going to be involved in the writing of the algorithm for this. I mean, you know, there are like some probably neuroscientists and complex, you know, like scientists who will be working on this. But actuaries will definitely have a role to play in pricing of these kind of things, in estimate of the risk. And as we said, if we you know, design a model which ends up actually discriminating some categories of population, or by design actually exclude, you know, some customers from the underwriting because of the way we would have designed it, and we don't have any control on it. I think we will be held responsible for that. So we will have, you know, like to make sure that as part of our design, we design it, you know, like not to introduce any bias. But I really think that actually with the rise of these models, there will be also new functions being created to actually validate the models. And you already see it. You got, you know, some model actuaries validating models and actually reviewing models and actually challenging the work of other actuaries. And I really think that it is going to be rising even further because when we will be basing all our decisions on models, and we don't know actually how the model works, because AI is a bit, you know, like a black box in certain cases. You know, the calibration of the models is difficult to explain. Whilst we were used to work, you know, with actuarial models, which are very simple to explain, very simple to calibrate. But if the models that we are going to introduce are going to be calibrated on a daily basis at very high frequency, and actually we lose control of explaining how it works, then it will be our responsibility to retake control on this, because we have to explain how it works, because what we do has an impact. It has an impact on the price. It has an impact on the stability of the company. The insurance company can fail if we have mispriced. It can fail if we have misreserved or misestimated the capital. And I think that's basically where I see the rise of new functions for actuaries, you see.
But a follow-up question, sometimes actuaries do face the difficult situation where, say, for example, the law says that in determining the premium for the car insurance, you can't really take into account gender information, but the data maybe says otherwise. So what's your view on this?
Oh, I'm very clear on that. Historically, we used gender because it was data that was readily available and was very highly correlated, or quite highly correlated, with the outputs. However, we have no reason to believe that gender is causal. It's just correlated. We always have to remember that correlation is not causation. And therefore, just because it's correlated, if we charge somebody who's one gender or another a higher premium, it may be actually completely inequitable, because there may be nothing about that particular person that is going to make them a higher risk. So what we always need to do is to think about finding data that we are clear is not just a high correlation, but preferably there is something that is absolutely related to the drivers of risk. Gender is not a risk driver typically for car driving safety.
Any other comments?
I think potentially this is where maybe you see like complex models will be helping actually to eliminate this bias, because bias comes from simplicity. It comes from finding some homogeneous groups, you know, which you can all compare and price actuarially. But if you are too simple, you generalize, like common behaviors and traits, and then you end up discriminating and creating bias and making some decisions, excluding some groups or pricing up, some people based on these common traits. I think that the rise of complex models and big data should solve that, because we should be going to the micro level, and we should be taking all the idiosyncrasies of people as opposed to common traits and generalizing and pricing actually. I think that to a certain extent we should solve that. It's just that we need to make sure that we do it, and we do it, ethically. And we need to keep control on this. But I really think that the rise of the complex models and adding more data, big data, neural networks, looking at various trends and estimating a risk driver, but looking at every risk driver. And as we said, maybe move away from correlations and try to look at actually really an element of risk where you have more causality. I think that should help to solve this type of bias and exclusions and anti-selection.
Thank you. So one last question from me before I open the floor to Q&A sessions. As AI relies on more computing, its carbon footprint increases with significant consequences. So there's a recent study estimated that the carbon footprint of training a large NLP model is equivalent to more than 100 round-trip flights from New York City to Beijing. So yes, AI in this case going to be a double-edged sword in fighting against climate change.
Well, don't get me started. There is no such thing as a silver bullet. There is no single technology that is going to magically solve the problem. AI could turn out to be useful. It could turn out to be a big environmental problem. We're already seeing some new technologies be major carbon footprint problems. Blockchain, I'm talking about you here. So, as with all things, we have to look at the big picture. Personally, I would not fly 20 times between New York City and Beijing for pleasure, because I try not to fly, because I believe that my carbon footprint is important. Increasingly, we're seeing many corporates commit to going net zero by 2050, 2030, wherever. They are going to have to think about how they use their carbon budget, whether they think that AI, machine learning, blockchain, whatever, is a good use of their carbon budget. So I think it will have an effect, and it may stop people using hugely compute-intensive AI techniques for things that don't deliver enough benefit to be worth spending the carbon budget on. Carbon, think of it as spending your budget. Think of it as spending money. There are some things that you wouldn't spend masses and masses of money on. There are some things that you wouldn't spend masses and masses of carbon on, but there are some things that you would.
If I can add to that, we are in the insurance industry, so it's not like we are consumers of the very intense energy sucking techniques like deep learning, for example. But there are ways. By the way, I mentioned in my presentation the solution of the universe, the number of the universe, 42, and the Diophantine equation. This was actually solved in a very green way by using distributed machines all over the world. So it was about 500,000 different PCs that they were functioning anyway. And this was actually solved in a very, very green way. So I think we might see some solutions to that as well. But I don't think we are the industry that our AI is so consuming at the moment.
And we would expect, like new maybe technologies also to emerge, like quantum computing, for instance, which should solve, like potentially also some of these computing, like power problems. But I agree with you, Dimitrios. I think that there are ways of distributing, and using parallel computing to solve actually some of this problem. And it's as we said, it's all depending on actually whether there will be a cost to that computing power. If you have to put like machines in your room to make it work, you feel the heat and the cost. If actually this is actually on the cloud, it's also costly, but you don't really feel that. If you have to have actually some cost to your carbon footprint, maybe that's something that people will be looking at a little bit further. Indeed, it's a cost of capital, more or less.
Yeah, as adding to that, I mean, technology is improving all the time. Technology is becoming greener all the time. I mean, I expect cloud computing and technology to embrace the environmental impact of all this. I mean, so I think, was it on BBC News like a few months ago, they were thinking of putting like a data center underwater just to to keep them cool and reduce their heat. So I mean, there are solutions out there. And yeah, we just have to wait and see what the answers are.
Right, thanks everyone. I'm now opening the floor to Q&A sessions. The first question is a slightly more specific one. So that's from Dan, who asked about the process in choosing one AI technology as opposite to another to assist the actuaries on the project. So what's the actual process in practice for you to decide which technology to use?
What does Dan mean by technology? Does he mean algorithm, or does he mean platform like or a language or libraries? Are we going to use TensorFlow or Python? Are we going to use, or is it about the algorithm? Maybe Dan cannot reply, but maybe I can answer both. If it's not specific. So basically, the way we have handled it in teams that I have led in the past, so we're trying to use as much as possible technologies that are popular and familiar. So we are not going to deviate. So we are going to stick to things that are open source. We're going to stick to things that are actually, we will find a lot of knowledge out there, which is for free. So we will use Python, mostly Python. If we're going to do something very statistical, we're going to go to R. We're going to use R because of we like certain libraries. And there were cases where we have actually even used MATLAB. This is just some examples. In projects that we worked also with clients, I worked with as a consultant with clients. We were very much favoriting not replicating everything from scratch. So, for example, if a client had a strategy and was comfortable with cloud, and he wanted to use one of the main cloud providers, AWS, Azure, for example, or Google, we were actually favoriting that as well, because there were already a lot of tools in those platforms that were fine for us to do our work. In terms of the algorithmic side, I don't think there is an easy answer. I think I said before that we're moving away from that traditional technique, and we have seen so many examples where random forest, gradient boost, especially gradient boost, has overperformed over the traditional techniques like GLM. But at the end of the day, every case is different. And in my opinion, you have to try the different algorithms, do the validation, look at the curves, look at the accuracy, and then decide, depending on the problem, depending on the type of data, depending on linearity or non-linearity, what we're going to use. I hope that I answered to Dan, if that's what you wanted.
So actually, can I maybe just add one point actually on this, Dimitrios? I really think your point on the open source is also quite interesting. And I might ask that question to the floor, to be fair, because it's something that also is potentially, like a challenge for the profession. With the rise of open source technologies and libraries, the reliance of our models on libraries which haven't been validated. They've been used, yes, they've been checked, but they haven't been validated. All our models could be relying on libraries that might be, like, I don't know, erroneous. And that's something that is definitely a challenge for the industry. Because, like if you see, for instance, the rise of these open source platforms with complex models, because they're complex models, where maybe one single library could have a common error that is then transmitted to all the industries, and there is absolutely no control on this, potentially a capital model used by GI insurer using that particular module could create a bias error of maybe 10%. And this is
Loren, you are absolutely correct. If I can exactly answer to that, that comes to me to the deployment side, how you deploy something. So there are two things, the way I see things. There is the laboratory and there is the production side, or as we call it in the industry, from lab to life. And in the laboratory, I'm a very big fan of open source. I'm a very big fan of what is out there. I'm a very big fan of what is in academia. But when it comes for it to be deployed, it's a very different story. It's a very difficult story.
Yeah.
So what I have done in my case, what we have done in situations where we worked on projects like that, we were on parallel having different solutions. So we had the old one that was maybe not so sophisticated, but it was approved, it was audited, it was checked. So let's say reserving. We had the old method, which was not the most sophisticated, but it was the one that was audited, and it was the one that the chief actuary, in some cases myself, I was signed off, and I was regulated on. But then we had some other, let's say, methods that we were testing. And in some cases, we were running things in parallel until we were getting enough validation that there is enough accuracy to deploy it.
But this is exactly why I raised the question. So you see, I think the choice of an actuary to use one method is you need to be able to redo it yourself and explain it, because if you rely on something that has been built by someone, it's not good enough. And I think that's something quite critical in the actuarial world. When you build a model, you need to be able to validate it, explain it, and it needs to be bulletproof, because the output of that model are going to drive the price of the insurance policy, the profitability of the business that you're going to work for, and potentially it's survival. And that's why I think the open source concept in a regulated profession is going to be complex. And there are still softwares, which are actually used by actuaries, and they are actually commercial, and commercially proven, because our people paid to validate, audit, review, and make sure that the libraries that you use are actually correct. And I still think that they are the ones that are going to be used for reserving, for pricing, and for capital modeling in the insurance industry.
There as well.
I think there's two things here. One is that you use different technology for prototyping than you do for developing production software. There's usually implications of resource use, how long the damn thing takes to run, for example. My husband has worked in machine learning for 40 years, and he sees new people coming in, developing in Python, developing in R, and which is fine for proof of concept. But if you're trying to do massive computation, that doesn't work. You have to actually implement in something like C that can, really, really bring the power, the compute power to bear, and if you're trying to do real-time analysis, which he is for some of his work, you simply can't wait for Python to operate.
You can turn on parallel computing and do some very, very, very fast computing if you want.
On the open source issue, it's very interesting that people in computer security are very, very pro open source. They do not like proprietary security algorithms. And that's because if it's open source, you've got scope for enormous numbers of people to check it and find mistakes. If it's proprietary, you've only got a very, very limited numbers of pairs of eyes that can look over it and find the mistakes. So in many ways, for really sensitive applications, you're better off going open source because you're much more, all software has bugs in to start with at any rate, and most of it has bugs in throughout its life. And if you, so if you're doing something really sensitive, using open source gives you actually much more chance of finding the bugs.
I agree completely, Louise. I think from a statistical point of view, you're better off using open source.
Thank you.
From a legal point of view.
To next question.
Yeah.
Sorry about it. So next question actually is a very practical one from Max. He asked, what do you advise pursuing an MSc in data science over an MSc in statistics, considering the crossover between data science and actuaries? Which would be more useful? And I would like to add how about a PhD as well?
Depends on the syllabus, right? I mean, it's a title, data science and statistics. But I would expect, I mean, and maybe you, Yining, are more appropriate to answer this question since you are in academia.
I think it depends so much on you, what you're interested in. If you're going to do study at the MSc or PhD level, you have to study something you're interested in. You can't do it just because you think it might be useful. That would be wasting a year or two of your life doing something you hated. You know, why do that to yourself? Choose something that you think is interesting.
But if you want to become a hardcore data scientist, if I may ask this, I think a PhD helps. If you want to become hardcore, someone that really can go deep into something, then I think, and there are jobs for that, it's useful to be really hardcore. Then I think to be in a research degree, I think that would help and be appreciated in the industry as well.
It also, I was thinking, depends on what you define by useful. What would be more useful? Would you be useful to yourself? Would it be more useful to try and get a job, or would it be useful to help you in that job? So these are different things that you need to consider about what we think is useful. But from my point of view, obviously data science has been taken over, and it's been well, not taken over, but it's been more popular. And MSc statistics is also really important in giving you that solid background in statistical techniques. I mean, either is good. I mean, it's all up to you really and what you enjoy, and what Louise said. You don't want to be too hard on yourself if you're doing something that you don't enjoy.
And maybe one final comment. I think, you know, like, it's always good to have some work.
Might be a connection issue there.
Yeah, we use this technique in real life. You know, this helps.
Lauren, could you say it again? Because I guess there might be an internet connection issue there, so we didn't hear you very clearly previously.
Sorry for that. Yes, sorry, my internet was instable. Now, I was just saying that also one thing which helps is to get, you know, work experience, and actually get, you know, very quickly to use your techniques in practice, in a practical job, even for a short amount of time. It helps, and it could drive also your decision in one direction or another, depending on that.
Okay, thank you. Another very practical question from Yan Qing, who asked about the ideal programming language to learn.
When I was a software development manager, I wanted people who could program in a number of different languages, because that way they'd been exposed to more different ways of doing things, and they would be good at learning the next language that they had to learn. I can't begin to tell you how many languages I've programmed in my lifetime. Every 5 years or so, I had to learn a new language and to become an expert in that.
It's a very hard question as well, because every applications, every business will have their own preference. Every individual will have their own preference.
Yep.
try to be as versatile as possible.
Yeah, for sure. I mean, yeah, as I said, and the main thing is the business has the different preference. You could be a Python expert, all of a sudden you're working for a company that uses R or that uses TensorFlow or whatever, and then you need to be able to adapt. I mean, it's all about having exposure to as many, or the main languages as possible, just so you can understand and be a more better fit for your organization. Basically, I mean, you can't predict what the next language is going to be, so you might as well just have a good understanding of all of them.
But if you're learning now, I'd actually highly recommend learning Python. It's a fantastic language. I really enjoy programming it, and it teaches you quite a lot. But that's just a fun thing.
Yeah, this is what I want to say as well. Based on again, putting my consultant hat, to give a very practical answer, I would say two things. One, SQL, absolutely necessary, and one, Python at the moment. Because you cannot ask someone to learn 1 million things. So if someone starts, I would say absolutely necessary SQL, because 80% of the work is data manipulation and extracting data from certain sources. And then I would go with Python, which is also quite easy. And then from that, he or she can move on.
Yeah, and I'd also just add, don't perhaps wait too long on, or try and research what exactly, or do too much research into what language you want to do. It's better just to learn something a little bit than when waffling over or wasting time trying to research what the best language is. But Python is obviously a very good one.
And also, I mean, just go online and try to play by yourself, because there is so much available already. There is so much resource available online, and it's, I think, the beauty. I mean, like your current world is amazing for that. I didn't have that when I studied. I had to read books. I didn't even have a laptop. You see, so the thing is that now I think everything is accessible. You have actually students all around the world who are doing this and who have done it in the previous years. It's all available, so you can actually look at tutorial, learn from scratch online, and find some notebooks that you can use. I think this is actually the best place to start, really.
Thank you for the very practical advices. Now back to AI. Samuel asked about your opinion for what sort of analysis that are not possible now for actually will become possible in the future with AI.
Okay, I've got one. Surprisingly, in the field of pensions, okay, typically when you do pensions work, you assume that salaries are going to go up by such and such per year and so on, and it's all very very boring, really, on that front, that you don't take account of the fact that there are different people who are going to have different type of career histories. I've actually done some work trying to take salary histories of people, of long-term employees, quite a large number. This was on a national scale because it was the state scheme, so possibly not suitable for many employers, and using k-means to cluster the career histories into clusters so that you could get an idea of the sort of types of groups of career histories there might be. You might get a group of high flyers, for example, with their salary going up rapidly. You might get people who get to a particular level and then level off and so on. So things like that, I think things analyzing populations of policyholders, of pension scheme members or whatever for changes over time, and that will then help us do projections into the future, because we can think more about how things may change over time, and not assume that we're going to have sort of average salary increase rates and all that sort of thing. I've stunned everyone into silence on that one.
I'm not sure I fully understood the question. I think the question was about how AI will enable us to do certain things in the future that now we cannot do, right? Yeah. So just to give an example I was in a discussion with an insurtech in the United States a while ago, and one of the big problems that the insurance industry wants to solve is, underwriting, to make it more user-friendly, to make it quicker, and to make it more robust. So there is this company that they're working particularly for the protection business, so income protection, critical illness, term life, etc. And what they're developing is an AI solution that, by looking at the face of the applicant, they will extract characteristics that they will be able to identify age, they will be able to identify certain things that are maybe a little bit obvious, but also non-obvious things which are related to morbidity. Now, I'm leaving the ethical side. I mean, I'm excluding that from the discussion now, how ethical it is, et cetera, and from a regulation point of view. But I'm just demonstrating here the capabilities, especially in one area where AI is really outperforming human beings. So AI is outperforming human beings at the moment when it comes to imaging. And this is something that technology institutions out there are exploiting. How? By capturing the human being that are able to conclude to to make insurance conclusions. This is just one example, maybe how the future will look like.
Yeah, so I can also maybe give some examples, some practical examples of how I think AI helps now to solve some insurance problems. Most of the insurance policies on the property side, so on the general insurance side, are insuring some physical damages. You see, some things which are obvious. Insured events are obvious; they need to be material. So it's like a business interruption which results from a physical damage. It's a financial loss which results from physical damage. So there needs to be something obvious. The thing is that there are lots of risks that are actually not materializing obviously, where like the lags can be weeks after the events or months after the events. You have some contingent losses that are actually impacting. You don't even know that it was actually related to that event because you perceive it, but you don't know, you can't put a link to it. AI would help to do that. If you look at the data and you see a hurricane event can have an impact on the lack of supply, can have an impact on your asset value, it can have an impact on your revenue, it can have an impact on the airport closures 100 kilometers away from where you are. So technically the hurricane might not have caused any physical damages to you, any obvious losses, but might have caused some losses which would have resulted into losses, indirect losses to you. And I think that's really where AI is very, very interesting, because you can create some new products which links to a peril, where you can cover more losses that were not covered before. And I think that's where really we are going to see a rise, I think, of new products, where you're going to look at maybe a peril and try to assess actually all the potential consequences that peril would have had on an individual, and actually take the holistic view. And I really think that this is going to be like one of the areas where AI could be used a little bit more.
Thank you. In the interest of time, one last question, this time from Chalani. So let's come back to climate change. Climate change has resulted in extraordinary damage, natural disasters in the past few years, and assume that it will continue to happen until major steps are taken. But this has affected a lot of insurance companies, since the data we have about natural disasters, actually in the past will be very different to what will happen in the future. Will AI be effective in pricing and predictions? So in a more general context, it's asking about what will happen if the data you have is not stationary.
We can't predict the future. AI can't predict the future either. If nothing like this has happened before, there is no data to go on.
So it's actually a very good question, because most of the, so if I think that one of in the question you link to hurricanes. So it's interesting because most of the hurricane models which are used for the moment are calibrated using historical data. So the frequency of the hurricane and the intensity of the hurricane is calibrated based on data from the 1900s, or let's say like the last 50 years, really, the last 50 years. The thing is that in the last really years, we see the rise in the frequency of hurricane. We see the intensity also being, quite unpredictable. And that actuarially, you can't really correct it. So all the models that we were using in the past might not be correct. So I really think that AI could be helping here by adding more data, by looking at more complex data sets, to see how maybe changes in current environment conditions could have created the conditions where the frequency would increase. And that would help to correct the past and put the data, like more on level with the current conditions and therefore forecast them. Because the big problem that we have is correcting the trend. And the techniques that we use at the moment, actually speaking, are basic. And I think AI could help to correct these trends by understanding the drivers, like of what caused really this increase in frequency or increase in intensity, and therefore project more correctly how the future will be looking like. Because at the moment we are kind of navigating in the dark, and really the models are not good enough for this.
If I can add one thing to what correctly Laurent said, we cannot avoid the black swans, right? So the black swans are always going to be there, and we are going to be unprepared. So there is no magic. But as AI is developing and we're moving from narrow AI to maybe general AI, one of the challenges of AI is how we will be able to work with small data, not just with big data. So there is a big research going on at the moment, how we can be accurate with small data. And the other thing is how we can capitalize on knowledge transfer. So train our models in another environment, but get conclusions and results that can be used in another environment.
Yes, and also actually to answer to also that question, there are some techniques which are used, some bias techniques and AI bias techniques which are used to expand a universe of information and project very extreme return periods from very little there. And these techniques are used in climate change. So in the very complex climate change from the UK Met Office, for instance, they are able to project 5,000 years return period or even further. And they do that by applying some complex Bayesian and AI models to extrapolate really everything possible from very little information. And that is actually
probabilistic graphical models.
That's
this
it.
is what
exactly. And that's using these new techniques. It's pretty new techniques, you see. It's not something which has been used for a long time. And I think that's definitely going to rise, you see. That's going to help us to understand a little bit more how the future will look like.
Hey, that's the end of the Q&A session. I would like to thank all for panel discussants again for their excellent participation. But I would also like to thank all the engaged participants for asking questions and listening to us. I'm now handing over to Stefano.
Thank you, Dr. Chen, for moderating today's event, and thank you to our panelists for the insights that you shared with us today. As this marks the end of today's event, I would like to invite everyone to turn on their cameras as we will now have a photo session. Okay, I will now count down from 5. Everybody get ready. 5, 4, Three, two, one. Okay, thank you. For everyone, remember to scan the QR code and fill up the form to mark your attendance and stand a chance to win a £10 Amazon e-voucher. And for those who have participated in the first session, you will still need to fill up the form to record your second entry. Before we end today's conference, I want to thank a number of key people who were instrumental in organizing this event. Firstly, thank you to the speakers who are sacrificing your time to come discuss these issues with us. Your insights and experiences are tremendously valuable, and all of us here look forward to implementing these in the future. I would like to also thank all the participants who took part in today's event. Your participation is greatly appreciated and really makes this whole conference a tremendous experience. I would also like to thank the sponsors of our society, our gold sponsor, Genre, and our strategic partner, the Institute and Faculty of Actuaries. Without such generous support, none of this could have happened, and we are incredibly grateful. Finally, I would like to thank the previous and current committee for the countless hours spent preparing for this event. And for that, we offer our deepest gratitude. Once again, thank you for attending and have a great afternoon. For those who have not scanned the QR code and filled up the form, please do so as soon as possible, as the lucky draw session will begin shortly. At the end of the session, we will have 3 lucky winners who will each be taking away a £10 Amazon e-voucher. We will give you 2 minutes to fill up the form.